According to the law of the conservation of mass, the mass of the products formed in a chemical reaction must be equal to the mass of the reactants consumed in chemical reaction. According to law of conservation of mass, the mass of the reactants always equal to the mass of the products. So dear students, in a chemical reaction, the total mass of the products formed in a chemical reaction, the total products formed in a chemical reaction must be equal to the total mass of reactants consumed. It is the law of conservation of mass. According to this law, the number of atoms of each element in a chemical reaction at reactant side and at product side should be same. That's why we need to balance the chemical equations. So dear students, according to the law of conservation of mass, the mass of the products formed in a chemical reaction must be equal to the mass of the reactants. As per this law, as per the law of conservation of mass, the number of atoms of each element before reaction and after reaction must be the same. So we need to balance the chemical equations as coefficients. Noted. Students, to balance the chemical equations, some points should be remembered. Follow these points. Don't disturb the formula. Suppose H2O is there. This is the water formula for water. To balance the equations, don't put here 2, 3 or like that. Don't disturb this formula. We balance the equations with multiplying with coefficients here. 4, 5, 2. Just to multiply with the numbers. Choose to balance more atoms of element first. The atoms with more elements, that should be balanced first. Final equation must be fractions free. There should be no fractions in the final equations like 1 by 2, 7 by 4 like that. And the final equation must be smallest whole numbers as coefficients. As multiples, there should be smallest whole numbers. These are the points to remember. First we have to balance more atoms of element. Yes students, observe this example. Propane, this is C3H8. Propane is reacting with oxygen to give carbon dioxide and water, vapors and heat. To balance this equation, first we have to make a table with reactants and products or LHS or elements. What are the elements first here, present here? Carbon, hydrogen and oxygen. Now at LHS side, means at left hand side, what are the elements? Carbon. How many elements are there? Carbon atoms, sorry. Carbon 3 atoms, hydrogen 8, oxygens are 2. At RHS side, right hand side of the arrow, at product side, carbons are 1, hydrogens are 2, oxygens 2 plus 1, 3 oxygens are there. So how should we balance first? We choose to more atoms of element. Here more atoms of element is what? Hydrogen is there. What is there? Hydrogen. Hydrogen has 8 here. So here left hand side 8 hydrogens are there. Right hand side only 2. How can we make 2 hydrogens to 8? Don't write here 8. The formula will be disturbed. Remember our condition. Don't disturb the formula subscriptions. Just we have to choose multiples to balance that. Here 8 oxygens are there. To multiply to become it 8, we multiply with 4. So here we multiply the H2O with 4. This 4 multiplies not only hydrogen, it whole water H2O, it multiplies hydrogen and oxygens. So here it became 8 hydrogens. So hydrogens are balanced here. So when we multiplied it with 4, what next? Carbons are there. How many carbons here? 3 carbons. So here we multiplied with 3. How many carbons are there? 3 into 1, 3. Now it became 3 carbons. So here also 3 carbons. So 3, 8. Now look at oxygens. Here oxygens are 3 into 2, 6. Here 2 oxygens, 2 into 3, 6. Here 4 into 1, 4 oxygen. Total 10 oxygens are there. At product side, 2 into 3, 6 plus 4 into 1 oxygen, 4. Total 10 oxygens present at right hand side. So here oxygens are 10. Here carbons are balanced, hydrogens are balanced. Next, 10 oxygens at right hand side. To balance the oxygens at left hand side, how many present there? Only 2. How can we make them 10? Right, we multiply with 5. So here 10. 2 5s are 10. Now check out carbons 3, 3, hydrogens 8, 8, oxygens 10, 10. So the number of atoms of each side, left hand side, right hand side, are equal, same. So this equation is called balanced chemical equations. Like this we balance the chemical equations. So first we have to balance the element which has more atoms. Okay. The unbalanced equation is called unbalanced chemical equation. Unbalanced chemical equation is called skeleton equation. Now this is the balanced chemical equation. Before that it is skeleton equation. We multiplied with some numbers and make it balanced chemical equations. Observe this. Here elements are ferrous, hydrogen and oxygen. LHS side, RHS side. Ferrous. So here elements. If you observe this equation, ferrous plus H2O gives rise to Fe34 plus H2. Now here ferrous is 1, hydrogens are 2, oxygen is 1. Here ferrous are 3, oxygens are 4, hydrogen is 2. What is the more elements, more atoms of element here? Oxygen. So here oxygens are 4. Here only 1 oxygen. Here if you multiply with 4, 4 into 1, 4 oxygens, then it is balanced. Oxygens are balanced. 4 into. What happens then next? Ferrous is there. How many? 3. So we'll multiply with here 3. Then it becomes 3. So ferrous 3 atoms here. Here we multiplied with 3. Next hydrogens. How many hydrogens are here? 4 into 1. 4. Sorry, 4 into 2. 8 hydrogens are here. Here 8 hydrogens. To make it balance 8 hydrogens, we simply multiply with here is 2, 4. 4 to the 8. Now check once. Here 4 to the 8. Ferrous 3, 3, hydrogen 8, 8, oxygen 4, 4. This is the balanced equation. 3 into Fe, 3 Fe, here Fe's are 3. 4 to the 8 hydrogens, here 4 to the 8 hydrogens. 4 into 1 oxygen, 4 oxygens, here 4 oxygens. So like this we balance the chemical equations. This is the balanced chemical equation. Now you can do easily. First what we have to do? First we choose the atoms of element with more atoms. Here 12 hydrogens. Here at right hand side, LHS side, RHS side. Elements: carbon, hydrogen, oxygen. Here 3 carbons, 6 hydrogens, 3. Look at this example. This glucose converts into cetyl alcohol and carbon dioxide. Now what we have to do first? We have to choose the more complex substance or the element which has more atoms. Here hydrogen has more atoms. Look at this. First we balance that hydrogen. Here at reactant side, at LHS side, how many hydrogens are there? 12. To make it 12, at right hand side 5, 1, 6 hydrogens are there. We simply multiply with 2 the entire substance. So if you multiply here 2, 5 plus 1, 6 oxygens. So 2 6 are here, 2 5 is 10 plus 2 1s are 2. 2 5 is 10 hydrogens plus 2 1s are 2 hydrogens. Total 12 hydrogens. So it become 12. After that carbon has. Next, how many carbons are there? 6 here. So here only 3. To make it 6, we cannot multiply here 2. We can multiply with 2. Here how many carbons are there? Carbons are 4. Remaining 2. So here to make 2 carbons here, only 1 carbon is there. So we multiply with 2. 2 into 1, carbons are 2. 2 plus 2, 6. 4 plus 2, 6 carbons. So are you following, students? Here what we have done, the most complex substance element with more atoms, hydrogen, are balanced first. Here 5 plus 1, 6 oxygen, 6 into 2, 12 hydrogens, sorry. Next, carbons are 6 here. Here already 4 carbons plus, when we multiply 2 plus 2 carbons, total 6 carbons. So it balanced like this. Next, oxygens are 6 here. Here 2 into 1 oxygen, 2 oxygens. Here 2 into 2, 4. Total 6 oxygens. So it is 6. Check the RHS side, LH side. Here 6 carbons, 6 carbons. 12 hydrogens, 12 hydrogens. 6 oxygens, 6 oxygens. This is very easiest method. According to our textbook, we have to choose more complex substance, but it is not easy to in all cases. So to balance more complex substances, it is always not useful. We have to move another method, that is, first we have to balance metals, that after non-metals, and hydrogens and oxygens. Metals means we know very well: iron, magnesium, copper, aluminium, like this. Non-metals: carbon, nitrogen, sulfur. At more difficult level, at more higher level, we follow this rule: metals Dear students, according to our textbook, we follow the method to balance chemical equations. We choose first complex substances, but in higher chemical equations, some more complex chemical equations, we need to follow this method. First we should balance metals, then non-metals, next hydrogens, at last oxygens. This example, here Mg3N2H2O plus magnesium hydroxide plus NH3. If we write here elements magnesium, nitrogen, hydrogen and oxygen. Here LHS side, magnesiums are 3, nitrogens are 2, hydrogen is 2, oxygen is 1. Oxygens are 2, hydrogens are 2, 3, 5, nitrogen is 1. If you table the elements to left hand side, right hand side, this is the picture, magnesium's 3, 1. If you take more complex substance or more number of atoms, means here hydrogens, 2 ones are 2 hydrogens, 3 plus 5 hydrogens are there. It should be a little bit more difficult. It will come, but it takes time. Then we follow this metals. First metals. What is the metal is here? Present here? Magnesium. So how many magnesiums are there? 3. To balance the magnesium here, only 1. We simply multiply with 3. So magnesiums became 3 here. It is balanced. Check out it. Magnesiums 3, 3. Next non-metals. Nitrogen is there. How many nitrogens are at present left side? 2 nitrogens. Here only 1 nitrogen. To make it 2, we will multiply with 2. 2 into 1, here 2. So nitrogens are balanced. After that hydrogens. Check the hydrogens are there. 2 ones are 2 hydrogens, 2 into 3. Here 3 into 2, 6 hydrogens are there. Plus 2 into 3, 6 hydrogens. Total 12 hydrogens are present. 3 2s are 6, 6 1s are 6, 2 3s are 6. Hydrogens are 12 here at product side. So here hydrogens 12. How many hydrogens are at left hand side? Only 2. To make it 12, we multiply with 6. 6 2s are 12. Next, what about oxygens? How many oxygens there? 3 into 2, 6. 6 into 1. Only here 2 into 1, 2. 2 3s are 6 oxygens. So here 6 oxygens. Here 6 into 1, 6. So now check the balanced equation. Magnesium's 3, 3, nitrogen 2, 2, hydrogen 12, 12, oxygen 6, 6. So it is the better method to follow chemical equations. Dear students, in this example, copper oxide reacted to ammonia to give copper, nitrogen and water. So this is the LHS side, copper is 1, RHS side copper is 1, nitrogen is 1, nitrogen is 2 here, hydrogens are 3, here 2, oxygen is 1, 1. If you go for metal first, here metal is copper, here copper is balanced. Next we go for non-metal nitrogen, here 2 nitrogens are there. We simply put here 2, 2 into 1, 2 nitrogens. So nitrogens are 2 here. Next hydrogens. How many hydrogens are there? 2 into 3, 6. Here hydrogens became 6. When we multiplied it with 3, 2. This 2 into 3 became 6 here. So to balance hydrogens here 6, we multiply with 3. 3 into 2, 6. So these hydrogens are balanced. Next, what about oxygens? Here oxygens 3 into 1, 3. Right hand side oxygens are 3. Left hand side only 1. So 1 into 3, 3. This is the balance of oxygens, hydrogens and nitrogen. What about copper here? When we multiplied with 3 to balance oxygens, again here copper is disturbed. So how many coppers are there? 3. To make here 3, simply here 1, 3 into 1, 3. It became 3. So 3, 2, 6, 3, 3, 2, 6, 3. 3, 3, 2, 2, 6, 6, 3, 3. Like this we balance chemical equations by equal the number of atoms at both sides, means reactant side and product side.